Here we have a SAT math problem. Okay, let's go to the question. In the figure above, two congruent circles are tangent to each other and are internally tangent to the larger circle. Line segment AB is the diameter of the larger circle. If the area of each smaller circle is 10, what is the area of the shaded region? Okay, to get the shaded region in the given figure, what we have to do is we have to subtract the areas of the two smaller circle from the area of the larger circle. Okay, we have the area of the smaller circle, that is 10, and now we have to find the area of the larger circle. Okay, here let's consider the diameter of the smaller circle as just r, and here this line segment also represents the diameter of the smaller circle, then this is also r. Then what is the diameter of the smaller circle? That is 2r. Actually, this 2r represents the radius of the larger circle. Okay, here we have the radius of the smaller circle and also the radius of the larger circle. So this r represents the radius of the smaller circle. This 2r represents the radius of the larger circle. Now let me find the ratio of the radius of the smaller circle and the larger circle. Let me do it. Okay, so here first let me write the radius of the smaller circle r, then I write the radius of the larger circle, that is 2r. Okay, here for both the terms of this ratio, we have the greatest common divisor r. So we can divide both the terms of this ratio by r. Then r over r will just become 1. That is, this r will cancel out. And here r will cancel out. I am getting 2. Now I got the ratio of the radius of the smaller circle and radius of the larger circle. Okay, from this ratio, we can get the ratio of the areas of the smaller circle and larger circle. How do we have to get the ratio of the areas? For that, we have to square this term and this term. That is 1 square to 2 square. So this is the ratio of the area of the smaller circle and area of the larger circle. The value of 1 square is 1 and the value of 2 square is 4. Okay, from this ratio, we'll be able to get the area of the smaller circle and also area of the larger circle. Now, to get the area of the smaller circle and larger circle, we have to multiply the terms of the ratio by the same non-zero number, say x. That is, we have to multiply the first term by x to get the area of the smaller circle. 1 times x is x. To get the area of the larger circle, we have to multiply the second term of the ratio by the same non-zero number, x. Then we get 4x as the area of the larger circle. Already we have the area of the smaller circle that is given in the question, that is 10. So this x equals to 10. Okay, when x equals to 10, we can evaluate the value of this 4x. That is, we have to plug in this 10 for x over here. Then I'm getting 4 times 10 equals to 40. Okay, now I got the area of the larger circle, that is 40. Okay, now what we can do is we can find the area of the shaded region. Let me write the stuff over here. Area of the shaded region. Let me write it over here. Okay, as I said already, to get the area of the shaded region, what we have to do is we have to subtract the areas of the two smaller circle from the area of the larger circle. Okay, area of the larger circle is 40. Now let's get the areas of the two smaller circles. Area of one smaller circle is 10. Okay, to get the areas of the two smaller circles, we have to add 10 positive 10. Okay, here 40 negative 10 positive 10 is 20. 40 negative 20 is 20. Therefore, the area of the shaded region is 20 square units.